No. This
Oh,
was, I think, a few years. I think 2017. This was
okay.
2017.
Okay.
So we have so it uh, so we are given a function f which is continuous on the closed interval 0, comma 1.
2R.
Uh, yes, sir. Or actually, no, but the range is not relevant actually.
Okay.
So we will just say R for now.
Okay.
And the question is to find the limit as n tends to infinity
Uh,
of n times
hmm.
uh, 0 to 1, the integral from 0 to 1,
Uh,
x power n f of x dx.
right.
Yeah. So actually, I have no idea how to see how to do this. It's
Okay.
actually MCQ.
Yeah, but let's try to do it
So the
first.
options.
Yeah, but let's first try to do it.
Okay.
Yeah.
Okay. Yes, sir. So I was thinking parts or something, but then it gets messy and doesn't help in
Hmm.
the limit. So
Right. Okay. So, uh, yeah, like you can do it. I think you can try to do one of apply one of the techniques. Okay, you can try to break this something like this.
okay.
Okay, and then compute each of them separately, right? So
And delta is any positive, anything.
yes, I suppose, yeah. So take you fix a delta less than 1. Okay.
Okay. Yes, sir.
Right. I think if you fix a delta less than 1, then you see. Okay, I should not say the whole thing. Okay. Try to maybe it will be 0, right? So you can see. Okay. Right. So if
Okay.
you're
Okay.
thinking
Yes,
that
sir.
it is 0, which I suppose maybe what you're thinking, right? Then you should try to show that that if that this thing is less than epsilon, right? For sufficient n.
Actually, because I know the options, I know that it's not zero.
So
Actually,
0 is not in the option. Okay. Huh.
no, no.
All right. Okay. Then maybe that is okay. Then let us then actually try it and see. Actually try it with this delta. And see. Mm, hmm. Yeah, I mean, yes. I mean, that is what I mean. Like 0 means f of 1 or something, right? Yeah. Is it f of 1?
Yes,
Yeah, I mean, that is what I meant in my mind. Yeah. Yes.
yes. F of 1 is one of the options.
Yeah. That's what I meant, right? So you basically try to, yeah. So how do you say? Yeah. Yeah. So then you try this splitting. Okay. Try this splitting. And my
Okay,
point
okay.
was that here, this thing you can make as small as you want. Okay,
Right,
like
right.
like this
Yes,
limit, yeah, this limit. So for any delta, this limit will actually be 0. Fix
correct.
a
Yes,
delta,
sir.
and then that limit would be 0, and that you can show by actually, because this quantity actually you can make it less than anything uniform. Okay.
Okay, because continuous function has a maximum.
Yes, exactly. So you take this, and then this will
Okay.
be less than
Okay,
m,
okay, okay.
and this will be delta to the n and this. And when you take limit n tend to infinity, this
Yeah.
goes to 0. So the integral has to go to 0 because the quantity inside is less. But you
Yeah,
have right. You have to write the proof properly. So for any delta, and then this
okay,
one, you can try to show it goes. You can make this close to f of 1. This limit would be f of
right.
f of 1, and yeah, depending on the epsilon, you can choose your delta so that it is f of as close to f of 1 as needed. Okay, you can
Yes.
think of it. It
Yes,
is
sir.
not a difficult question. I mean, yeah, maybe this idea, but so let me see if I can say something which is more fruitful.
Yes.
So, but you understand this idea. This idea is used a lot. So basically, see, in a way, what we are doing is we are kind of concentrating the value of the function at 1 only. So we are making the other parts of the function negligible, right? Because
Right. Yeah, in the limiting sense.
in
Yeah.
the limiting sense, right? Because if x is, let's say, half, then n is large enough, right? Then f of half, the role of f of half becomes negligible.
Yes.
Right? So everything gets pushed to 1. Everything gets pushed
Right.
towards 1, roughly speaking. Yeah. And this n, you can understand, is sort of going to balance this n in the
Yeah.
integral. That's why
Yes.
it is kept there. And
Yes, sir.
yeah, there are other things possibly, but they are not coming to my mind right now. But you should do this. And probably one more thing which, let me see if I can say that. Yeah, what you can also look at it, you can look at it as, and this you will also be reading. So it's always good to look at all these things as special cases of something general. So what you can maybe think also is, what if you can ask yourself, what if I view this as Gn of x, right? So then you get a sequence of functions, right? You get a sequence of, like, you have sequence of numbers and you take the limit. So then here you have a sequence of
Yes, sir.
functions, you integrate them, then you get a sequence of numbers whose limit you are taking, right? So
Yes.
now you can imagine if what happens if you put this limit inside. If you are allowed to do that, then what happens?
Okay.
Like, obviously this is probably incorrect, but if you were allowed to do that, then what happens? Yeah. So obviously, what does this mean? This means, so first of all, that has to be very, very clear, right? This means that for every x, you are taking the limit.
Right. Yes. Yeah.
Correct.
Yes, sir.
Yeah, for every x, you
It's
are
just
taking.
treated as a constant, basically. X.
Yes,
Yeah.
exactly. Yeah, x is treated as a constant. So you see, if x is less than 1, then this limit is 0.
0
Yeah.
goes to 0.
Yes, but the problem is that if x is equal to 1, then this limit is infinite.
Right. Yes, sir.
Unless if f of 1 is 0. Yeah, but that is
Correct. Yes,
probably
sir.
a
Yes.
very, yeah, exactly. So yeah, so that you can, what you can do with that is you can, so you see, the point is that if f of 1 was 0, it would have been so good. Then this exchanging would give you the right answer. You see the point?
Okay. Yeah. Yes, sir.
Yeah, if f of 1 was 0,
Yeah.
then this exchanging would give you the right number, right? So why don't you
Right.
replace this, exactly, right? So why don't you replace this function by this function? You consider to do this. Yeah, you change the question. Means you're not changing the question, right? But you're adjusting. Yeah, so the question actually doesn't change because we cannot change the question. But then this thing now becomes So I'm calling this thing f tilde. Yeah. This, and then you have this. Okay. Yeah. Then you have this. Now you should see if you can deal with this problem separately. Now there are two problems, but they are, one is in our zone, one is where exchanging the limit gives the right answer. This is where exchange limit is allowed. Exchange limits means exchange limit and integral. This in this first part, right? And you should ask yourself
Yes,
if you
yes, sir.
can, right? And you should ask if you can deal with the second part separately. Okay.
Okay, yeah.
But then you see, it does not really help because see, when you're dealing with the second part, f of 1 you can forget about, right? It is the integral whose limit you want to calculate, right? F of 1 is just a constant now. Then you see that the second part comes down to showing that this thing is equal to 1 limit in the limit. Correct?
Right.
But that you
Yes,
can
sir.
do, you can integrate these things, right? It's an explicit
Correct.
integration. So this is obviously true. Like anyone can do this, right? First time you learn
Yes, it
integral
is
and
one.
limit,
Yes.
it's trivial, correct? And this one is what you need to do. Okay. So now everything comes down to this following, that you have this, yeah. So yeah, that it is. I mean, let me write the same thing. It is the same thing. Yeah. You need to show that that in this case you can exchange the limit and the integral.
Yes.
Right.
And I
Obviously,
suppose since it's a continuous function or
but you have
maybe
to, but you see, you will certainly need to use this condition that f tilde 1 is 0. Mind you,
right.
right?
Yes, sir.
You have to use that condition. Otherwise, you cannot exchange. We have already seen it gives you infinity.
Yes, yes.
So you
Yes,
have
sir.
to, yeah. So think now. Now you should think that if you have a continuous function f tilde, you can just write it as g. So this is how you see, you translate it and you apply some more general result, and you put g. G of 1 is 0, g is continuous, and you try to show that you can exchange the limit. Okay, you can exchange the limit.
Okay.
So right,
Yes, sir.
and so how to, yeah. So just 1 second.
Yes, sir.
Yeah, just yeah. So in in this case, you can exchange it, because I will tell you a general result which allows you to exchange it, and you will see this will be a special case of that. So the result will be this, that if you have a sequence of functions g and x, okay, this, okay, then this is equal to,
Yes, sir.
this is equal to this, yeah, if uh, if this is less than some function g, okay, where for all n. Okay, so what we are trying to say is that you have a sequence of functions g and x, gn, right? It's a sequence of functions gn, and each of those functions is dominated by your function capital G.
Okay. Yeah.
Okay, that is the condition. And that capital G has a property which obviously is expected, that it is also integrable, meaning that its integral is finite.
Finite. Yes.
Okay, if this happens, then you can exchange. Okay, and now you can try to show that if you call this your g and x, this whole thing your g and x, then it is dominated by some function capital G. So you have to figure out a capital G in this case, and yeah, see if a capital G exists. Let's see, is there a capital G? So can you think of a capital G? So you understand like
Oh,
what I'm trying to say, because maybe this is the
yes,
first time.
yes, sir.
Right? This is your
For
function.
this capital G, we can
Ah.
just use the constant that you gave like before, the M.
But there is also
Since
the n, right? You have to also look at the n. Like if
oh,
this n is
okay.
also there. Yeah, I understand the x is there, it's nice, but this n is also there. So yeah, so what should we do? Yeah, correct. So I think what you are saying is you need to just show that this is less than some gx for all x and for all n. Okay.
Yeah. So we can just take nm x per n, g of x to be nm x per n, where n is
Capital G.
n itself. Yes, sir, capital G.
Okay. nm
And
x power n.
x per n. Yes, and m is the maximum of G
Okay.
in the interval 0 to 1.
Oh, sorry. That's what you meant. Yeah. Pick the max. No, but you see, your G should not depend
Yes, sir.
on n. That is the
But
problem, right?
oh,
I mean, this G has to be 1G. That's the challenge.
okay,
It has to
okay.
be 1G, right? See, this x power n actually you can replace by 1. That is not needed, right? Where x power n is
Yes,
less than 1.
yes.
But
That,
this n,
so
yeah,
how to get rid of the n?
the
Yeah.
n, yeah. So you have to use some balance here. You have to show that this is less than something, right?
Nx per n. Yes.
Yeah. And is it so? Is it less than so? Point here is, look. Point here is forget the small g, right? Because that is bounded by a constant, right? So that small g is not a problem. You agree,
Yes, sir.
right? That small g is not a problem.
Because it's
Yeah,
it's continuous, so it has a maximum. We
it
can
has a
just swap
yeah.
that out.
Yeah. Now, can you bound this? That's the challenge. That's the challenge. And
Nx per n.
I think you cannot bound it. That is the problem.
Yeah. I
You can
think,
feel it,
yeah.
right? Yeah, you can feel that, right?
Yeah.
And I think that is yes, you can understand this actually becomes unbounded, right? Or
Yes, sir.
am I saying something wrong? Given any n, yeah. What I'm saying is, yeah, it's correct. You cannot bound it. Yeah, you actually cannot bound it. You can prove that.
Yes, sir.
So
Yeah, I just graphed it, and yeah, on 0, 1, yeah, it is unbounded. So I'm not able to hear you.
yeah, I muted myself. I don't know how. Okay. Yes.
Oh,
So
okay.
what I'm saying is that, like, if you take, for example, n equal to 100, then you can take x to be 100 to the power 1 by or no, sorry. Yeah, if you take n equal to 100, then if you take x to be close enough to 1, right? Then this thing, this thing goes close to 1, as close to 1 as you want. If you take
And
delta to be, yeah.
yeah, it is basically 100 itself.
Yes, correct. Uh, yes, actually you have 1 also, right? Yeah, so it is 100. Sorry, correct.
Yeah.
So that general technique doesn't work, and that's why this technique of this breaking up into delta, I think, is superior in this case, in this particular case.
Okay.
Yeah,
Yes, sir.
this technique of breaking it, and you will keep meeting with this technique always a lot of times, and then you will understand when the situation, you
Right.
will understand that you have to apply this technique. Yeah.
Yes, sir. Yeah.
Right. So yeah, it's a good question. Yeah. Okay. So then so let's stop there for today. Yeah, we'll try to meet more frequently. Okay. Let's see. Maybe Saturday,
Yes, sir.
Saturday,
Yes.
Sunday mornings don't work for you, right? Either of the days.
No, sir. I still have my gym. I
Okay.
think till mid-July I have my membership. After that, I'll be free. in the
anyways,
mornings.
yeah,
Plus,
that
I'm learning the two-wheeler in the morning. So,
yeah, no, no. So
so
you
two
should
things I'll have to
you
do in the
should do
morning.
that. Yes, yes, yeah. That's you should do those things. Yeah, that's
Yes,
good.
sir.
Yeah. Okay, so I'll tell you maybe Sunday evening should be a good time. Is that fine?
Yes, yes. Evenings work. Yes, yes.
Yeah, same time Sunday evening, but I will confirm you.
Yes, same time. Okay. Yes, sir.
Okay then. Bye.
Yeah. Thank you, sir.
Thank you.